This video is part of a series where we build an entire FPV drone from start to finish. So if it feels like you're in the middle of a conversation that you missed the start of, that's why. If you're here for the information in this specific video, keep watching. But if you want to find out the full context for what's going on here, there's a link in the video description to the full playlist, and you might need to go back and start with video number 1. In this video, we are going to install the receiver in the quadcopter and bind it to the controller so that you can talk to it and tell your quadcopter what you want it to do. And the first thing you're going to need is your receiver. This is the one that came with the kit that I am building. And it's possible that at some point in the future, you will receive a slightly different looking receiver. One thing that they will have in common, though, is that they will all run ExpressLRS. You see, there are different control link systems that people could choose to use. Like a bad analogy for it is that like some people like Android phones and some people like iOS phones. Some people like Windows and some people like Mac OS. They're different things that do similar jobs in different ways, and different people have preferences about which one works best for them. The one that we're working with is called ExpressLRS, and without going into too much detail, it is very inexpensive and it is extremely good range and penetration, so you can fly your quadcopter mostly where you want to fly it without having to worry about a failsafe where your link gets too weak and your quadcopter basically drops out of the air. The ExpressLRS receiver has solder pads on it, which we're going to need to solder wires to, and you should have received with your kit 4 12-centimeter wires, a red, a black, I don't know what the other two colors are going to be. I think maybe yellow and white. I don't have yellow and white wires, so I've got green and blue wire. Don't let it stress you out. The color of the wire isn't what's important, although it is always good to use red and black wire for power and ground, just so there's no confusion about where the voltage is going. The receiver has a UFL connector here, and it is connected to a little bitty antenna. Hi there, it's Joshua from the future. Before you wrap your receiver in heat shrink or tape, take the antenna off, just sort of grab it by the copper there and kind of just lever it off a little. Be very careful, don't damage the UFL connector. Grab this little thing. This is the antenna holder for your ExpressLRS antenna. It should come with your kit, and it should have a little slit right here. If it doesn't have a slit, you can just go ahead and cut one with a little razor knife or something. We're going to slide the cable in through that slit. Open that up. I'm just going to slide that in. We're going to slide that through, and this will go. It's snug, but that's on purpose. There we go. I got it in. It's just going to go in just like that. Don't resist the urge to pull on the cable like this. You will damage it. When that's all the way in, that should just kind of close over it like so, and that's roughly what you're going to end up with. Having done that, you can reinstall that connector and continue with the video. The first thing we need to do is solder the wires to the receiver, and the pads don't have any labels, so how do we know which wire goes where? Well, luckily, I've been doing this long enough that I just know, but also we could just look online, we could look at the product page for the receiver, and we could find probably a pinout diagram that tells us which pads are which. In fact, I'll put an image on screen of the product page for this very receiver, and we'll see if it's there. So I happen to know that the wiring order for this receiver is ground 5 volts TX RX, and this is the same TX and RX that we talked about when we talked about UARTs in a previous video when we were wiring up your video transmitter. Just to be sure everybody's on the same page, a UART, UART, is a way to pass serial data between the flight controller and some other device that the flight controller wants to talk to. The UART has a TX and an RX pad, and TX on the device goes to RX on the flight controller, and vice versa. But there's a common point of confusion when wiring up an ExpressLRS receiver, and that is you have to remember which side you're counting from. In other words, is it ground 5 volts TX RX, or is it ground 5 volt TX RX? You see, it's left to right or right to left. And the way to know the answer to that is to look for this little double pad here This little double pad here indicates that this is ground. Once again, I only know that because I've done this so often that I've basically memorized the wiring diagram. You can take my word for it. You can look it up if you really want to. I just don't want you thinking you would be expected to like know that somehow. Here's what that's going to look like with your wires soldered on. It's going to go black, then red for ground and 5 volts. Stick with that convention, trust me. And then for TX and RX, you can just make a note of which color is TX and which is RX. For those of you who watched my walk snail video installation where I explained the convention that I use about having the green wire R for RX go to the RX on the flight controller, you know why I put green here. And if you did the DJI and the analog video transmitter, I just didn't remember to talk about that in those. And well, you could go back and watch the walk snail video. There's a chapter marker for that little discussion if you're interested. One of the issues that comes up with receivers is the UFL connector may sort of pop off and become disconnected. It seems pretty secure, but it can be subject to a little bit of abuse during flight. What I like to do, sometimes it could just rip off by accident if you like damage the antenna. What I like to do is turn it 180 degrees and fold it back over like this. You do want to make sure that the little brass part isn't touching anything on the board. If some boards will have components close to the UFL connector that stick up and would make contact, but that's not the case here. I really wish it came with heat shrink, but it didn't seem to come with heat shrink. Perhaps they've included a piece of heat shrink in your kit that is good for use. You could put a heat shrink on there and heat shrink it with like a heat gun or a lighter. Or what I'm gonna do is use some of this Kapton tape, K-A-P-T-O-N. You could just use electrical tape if you have electrical tape, but the problem with electrical tape is you can't see through it, so you kind of need to see what the LED on the receiver is doing sometimes for troubleshooting purposes. So you want something clear or transparent, ideally. And I'm just going to tape that like so. And you see I'm also covering the solder points. Perfect. And that is going to provide a lot of mechanical stability. So if the antenna gets yanked on or something, then we're not going to end up with any problems. For this build, we are going to be mounting the receiver right on top of the video transmitter. This is not the ideal place to put it because the video transmitter is hot and generates a little bit of RF interference, but it is the only real place to put it on this quadcopter. Just for your perspective, there are some people who would do builds where they would put it up here behind the camera, and you would either need to get a longer antenna, which you would just buy separately, or they'll mount the antenna like vertically here, you know, but sometimes they'll mount the antenna out on the arm like this. We're not going to do any of that, but just for perspective, we're going to mount the receiver right here on top of the video transmitter. And I'm going to get another piece of double-sided tape. And for mounting the receiver, I like to use this stuff. It's called Alien tape. This was not provided in your kit, but if you pick up a batch, you will not regret it. It is amazing double-sided tape, and it is the only double-sided tape that I actually trust to hold a receiver in place all by itself. Wouldn't it be great if there was like a 20mm mount here? Ooh, that would be good. If you have a 3D printer, there's a guy out there. His name is Ridwan Hughes, and he goes by License to Drive on Thingiverse. And he makes amazing 3D printed mounts for receivers. And he actually has, I'm pretty sure, a 20mm sized mount for this receiver that would screw right into the holes on top of the video transmitter and be way more secure than like zip ties and shit. I'm gonna check my placement here and see that, yeah, I have a problem. This is not, do you see that these holes will not reach to the standoffs here? I have to move this back some. Dang, that's a shame. I'm gonna have to put it back here so that the antenna is long enough to reach to the standoffs there. Yeah. The reason I say dang is this. If I wasn't using a double-sided tape that I completely trust to hold on tight and not give off when I'm crashing and bouncing around, if I didn't trust this double-sided tape, Then I would back this up with a zip tie going around. Take a look. That would look something like this. But the problem is, well, you see that zip tie is right near this bind button? I would be just a little concerned about the zip tie pushing the bind button by accident. I wouldn't want that. Or maybe even moving and kind of busting the bind button off. So I kind of don't like that. Yeah, that's no good. So I could move the entire video transmitter back and mount the video transmitter with double-sided tape instead of the screws, but I kind of don't like that option. I like using the screws. It's nice. I guess the best solution is going to be to use a double-sided tape that I completely trust and give up the zip ties. I mean, you might be thinking, well, Bardwell, shouldn't you have like planned this out before you started working on the video? And I'm like, I want you guys to see how the sausage is made, right? That's what I'm talking about. Next, I'm going to give these guys a little bit of a twist to help keep them together. In fact, probably would be a good idea to actually just lift this up and twist it after it's soldered up, but I kind of wanted to see how long the wires need to be. We're going to be soldering these wires to, we need 5 volts, we need ground, and we need a UART to solder to. Now, one of the rules with UARTs is a given UART can only have one function. So if we have soldered our video transmitter to UART 3, which we did for the walk snail and the DJI, but not the analog, we cannot use UART 3 for the receiver. We need to find a different one. In this case, the only other choice on this flight controller is TX4 and RX4, which are right here. That is UART 4. And conveniently, we would hope that there is, yes, a 5 volt and a ground right next to it. So that's where we're going to solder our TX, RX, and 5 volt and ground. And that's going to be just about the right length of wire there. When we're done soldering it up, here is what it should look like. Obviously, the red is going to go to 5 volts and the black is going to go to ground. I see now that the wires themselves are covering up the labels on the pad, so you can't verify for yourself. But as always, I kind of want the wires coming to the center of the board so they can stay sort of tucked within the quadcopter. Then the other thing to be really sure about is that the TX on the receiver goes to RX on the flight controller. And I've done that using my color convention, where the green wire goes to TX on the receiver, so that I know that green goes to RX on the flight control. I can't tell if this is as clever as it feels to me, or if I'm just making up conventions to make myself feel clever. Anyway, let me know in the comments if you think it's really clever or if it's just dumb and I should stop harping about it. The bottom line is ground, 5 volt, TX, RX is the order of wires there on the receiver. TX on the receiver goes to RX on the flight controller. RX on the receiver goes to TX on the flight controller. If you don't get that right, you will be opening this quadcopter up later to swap those wires. The next thing we need to do is bind our controller to our receiver. And binding is the process by which this receiver knows that it is supposed to be taking orders from this controller. Imagine a scenario where there's 4 or 5 people flying at the same time. How does your receiver know who it's supposed to be listening to? Binding is the answer to that. You're going to need to bind every receiver once you get it. Once it's bound to the controller will remember that, and you can rebind it and move the bind if you need to, but this is just a process you're going to need to get familiar with. Now, the process of binding an Express LRS receiver to an Express LRS radio can be complicated and involve going to the computer and flashing firmware and bringing up a web page. Express LRS kind of likes to be complicated, sort of for the sake of being nerdy and complicated, but we are going to try to skip all that and do it the very, very simplest way. I want you to know that there's more to Express LRS than we're seeing here, but I don't think this is the right time to dive into that. I just want to get your receiver bound and get you in the air. Now, the radio that we're going to be using for this example is the Radiomaster Boxer, and it is the version of the Boxer that has the built-in Express LRS module. There is another version of the Boxer that doesn't have an Express LRS module built in. What you're about to see will not work, at least exactly as I'm showing you. If you've decided to use a different radio, like the Radiomaster Zorro, the Radiomaster TX16S, or some other radio, and if that radio doesn't have internal Express LRS, but maybe it has a module in the back, You will still be able to follow these instructions, sort of, but you may not be able to follow the exact button presses and instructions exactly as I show them. Sorry, can't make 18 different versions of this video for 18 different radios, so we just had to pick one. I also want you to know that I have created a brand new, fresh, blank slate model in my radio so that all of my pre-existing configuration doesn't cause me to accidentally skip a step that you're missing out on. But your radio is probably fresh out of the box and may have some pre-existing configuration from Radiomaster. So what I'm going to suggest you do is just work through these steps with me and make sure your configuration matches mine, even if you've got a pre-configured radio from Radiomaster. The first thing I'm going to do is press the model key and then page one time to the setup screen. And I'm going to scroll down. Actually, I'm going to scroll up and it'll roll me to the bottom of the menu because I know the option I want is at the bottom of the menu. I'm going to look for internal RF and I'm going to change that from off to Crossfire, CRSF. And if you're using an external module, you would do the same thing for external RF. Having done that, I will press the return key to back out. And the next thing I'm going to do is I'm going to hold down the sys key. And that should take me to the tools menu where you should see the ExpressLRS tool. If you don't see the ExpressLRS tool, then you're not using a Radiomaster Boxer or you're not using a radio with internal ExpressLRS. You may need to do some basic setup, and I have a video about how to do that. It's linked in the video description. It is my ExpressLRS Ultimate Setup Guide, and there are steps in there specifically for how to get your radio set up to use ExpressLRS. If you need to do that, pause the video here, head on down to that video and get your radio set up. Otherwise, we're going to continue. I'm going to click the jog wheel to open up the ExpressLRS tool, the ExpressLRS script. They call it a Lua script, L-U-A. It's a programming language. The ExpressLRS Lua script is running. All of these options loaded up. That's good. If that doesn't happen, you're going to need to figure out why, but that should happen. And then we're going to go down, and there's a couple changes I want you to make. First, I want you to change your switch mode. Your switch mode may be set to hybrid. I want you to change your switch mode to wide. I wish they would make the default wide and not hybrid. What's the difference? I think it's not that important to get into now. I just want you to make that change because I said so. Next up, I want you to look at the model match option. Do you see that model match is off? Leave it off. Don't turn it on. Unless you know exactly why you're using model match, it will make your life more difficult, make your receiver not work. I only say that because like 3 or 4 times a month, someone says, I can't get ExpressLRS to work, and it's because for some reason they turned model match on, and they didn't mean to. Don't do it. Leave it off. If you want to, you can adjust your transmit power. The higher the transmit power, the more range you'll get, but the faster your battery will run down. What I suggest you do is you set the transmit power to the highest value that your module or radio supports, and then turn dynamic power on, and that way it will go down to a low power when you're up close, but automatically ramp itself to a high power when you get far away. Finally, we're going to head on down here to where it says bind, and we are going to prepare to hit that option. Now I want you to notice that the receiver that I got specifically had a sticker on it that said pre-installed ExpressLRS V301. The Radiomaster Boxer ships with ExpressLRS V3 on it. In fact, we can see that if we scroll down here. Notice it says 321 ISM G24. 321. That's the version of ExpressLRS that's on this radio. If your receiver does not have ExpressLRS 3.x on it, you will not be able to bind it and you will need to update the firmware. I am going to hope to God that going forward, every receiver GetFPV sends out with this kit has ExpressLRS 3 on it, and you do not need to go through that process. But if you try to bind and it just doesn't bind, chances are the receiver has ExpressLRS 2 on it and will need to be updated. If you end up in that situation, there's a link in the video description below to a video showing how to update the firmware, and you will need to go do that. But let's cross our fingers and hope you don't. Next, I'm going to power up the quadcopter, and I want you to watch the LED on the receiver to see what it does. What we want to see is that the receiver is going blink, 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 blink. That means that the receiver is in binding mode. In this case, the receiver is not doing that. It is going blink, 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 and that means it's not in binding mode. It means it's just waiting for the radio that it's bound to, except it's never been bound, so I don't know what it's waiting for. Some receivers will automatically go into binding mode as soon as you power them up. This one has not done that. So here's what we need to do. In order to put an Express LRS receiver into binding mode, we will power cycle it quickly 3 times. I want you to watch how I do this. I'm going to wait for the LED to turn on and then unplug it. Ready? 1, 2, and third time I'm going to leave it plugged in. 3. And do you see that now the receiver is going blink, 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 blink. It is now in binding mode. Next, we're going to go to our radio and we're going to activate bind here. It's going to say binding. And then it's going to say connected. Do you see it says C connected here? And do you see it says model mismatch? Why does it say model mismatch? Model match is off. Why does it say model mismatch when model match is off? That's not possible. I've gotten exuberant and I'm doing my Seinfeld voice by accident. What's the deal with model mismatch? You know, Seinfeld never said, what's the deal? Look it up. It's true. Captain Bry, time to reach out to an Express LRS dev and bother them. Okay, here's what we need to do. The whys and wherefores of this are silly, but for whatever reason, this receiver ships with model match enabled. That's stupid because it prevents you from binding. Here's what you need to do to fix it. If you run into this, we're going to go in the Lua script. We're going to turn model match on and then turn model match off again. And then you should have a solid green light and no error message here at the top of the screen. Congratulations, you've bound your receiver, and Express LRS has once again proven that it is cheap and effective, but it will always throw you a curveball. Thankfully, you have me, and I have the ear of an Express LRS dev who I can whine at when I run into these situations. Okay, so now it's time to configure the flight controller so that it can receive signals from the receiver. And in order to do that, we have to power up the receiver. And what you're going to see is, I'm going to plug USB into the flight controller, and when I do that, you're going to see that the receiver starts blinking. Some flight controllers power up the receiver from USB. Some do not. If you come across a flight controller and you plug in USB and the receiver stays powered down, it's not broken, it's just, well, I mean, we could wish that all flight controller designers would do this because it lets us work on the receiver and work on the flight controller without having to plug a battery in, and our video transmitters overheating and our motors might try, who knows. So it's convenient when they do that, but not all of them do that. If someday you're working with a flight controller and you plug in USB and the light does not come on, you're going to need to plug in a battery. But today, we don't have to do that. So we see the C here in the upper right-hand corner of the Lua script, and we see the solid green LED on the receiver, and that tells us that the receiver and the controller are talking. They are bound together. But let's plug in USB to the flight controller, and let's go into Betaflight, and we'll go to the Receiver tab. And here in the Receiver tab, we have a readout that shows what Betaflight thinks the controls are doing. And you can see if I move the sticks, nothing happens there. There's no movement in these channels. In fact, these channels are at 1500, 1500, 1500, and the throttle is at 885. And that is a sign that your receiver or your flight controller is in failsafe. Take a look here in the Setup tab. Notice also that in the Setup tab under Arming Disable Flags, we have RX_failsafe. And this little pop-up box tells us that means no valid receiver signal is detected. So the situation we've got here is that the receiver is bound to the controller, they're talking, but the signal that the receiver is outputting is not getting to the flight controller. And the reason for that is that we haven't configured the flight controller yet, and that's what we're going to do now. But I wanted to take that second to clarify, because people will write to me and say, the receiver isn't bound because the flight controller is not getting signal. Binding simply refers to the connection between the controller and the receiver. The connection between the receiver and the flight controller is not binding, there isn't a name for it. It's just configuring your flight controller. So let's do that. And the first thing we need to do is go to the Ports tab, and we need to tell the receiver, or tell the flight controller, what UART number the receiver is on. If we look at the ports tab right now, Serial RX is enabled for UART 1, but we did not use UART 1 when we connected up our receiver. What UART number did we put our receiver on? It was TX4 and RX4, UART 4. So what we're going to do is we're going to disable Serial RX for UART 1, we're going to go down to UART 4, and we're going to enable Serial RX for UART 4. And when we do that, also take a look that nothing else is enabled on that channel or on that UART. Remember that one of the rules with UARTs is that only one thing can be used on a UART at a time. There are very few exceptions to that. They do exist, but in general, you don't want to see a situation where like you have VTX and Serial on the same UART. And in fact, if you try to do that, Betaflight will just wipe your whole ports tab clear and erase all the config that you already have. It's kind of dumb that it does that. Why does it not just reject the change that you just tried to make and go back the way it was? It's dumb. Okay, so we are going to enable Serial RX for UART 4 and hit save and reboot. And when we reconnect, everything is fine. I always like double check that I haven't wiped the configuration of the ports tab. But it didn't happen. Good, everything's fine. And then we're going to go to the receiver tab again. And things are, I'm impressed. Things are kind of working. They're kind of moving around in a stupid and wrong way. Normally, we would see that nothing was working yet. The reason that things aren't right is that we have not selected the correct serial receiver provider. So Spectrum 1024, remember I told you that there are different types of control links. We're using Express LRS, right? But there are other kinds of control links. Well, this is where you tell the flight controller what control link you're using. And if you look in this list for Express LRS, it's not there. And the reason for that is that FPV is confusing and unintuitive, and they just do things to make your life difficult. Though you need to select Crossfire, CRSF, as your serial receiver provider when using Express LRS. You just got to know that. Now you do. The other thing I'd like you to do is enable telemetry. And I'm not going to go into detail about what telemetry is or why you want it, but just take my word for it. For now, when you're using Express LRS, you should also enable telemetry. We got to draw the line somewhere, folks. And then hit save and reboot. And now, look at what we have. Throttle. My channels are moving. Let's see if they're moving correctly. By the way, at this point, if your channels are not moving, remember I told you that TX on the receiver goes to RX on the flight controller and vice versa? Go back and double check that, because don't just flip the wires and be like, no, I guess I'll just try flipping them. Go look at the wiring. Look at the wiring and see if you got the wiring wrong. Compare it to, look at the pinout diagram, follow the wires with your finger, and see which wire goes where. People just like flip the wires and they're like, sometimes it works, sometimes it doesn't, I don't know. Now that we have movement in the receiver tab of any kind that sort of corresponds, like not just random channels going nuts like we had a second ago, but actual throttle down, throttle up, left, right, up, down. Now that we have that movement, we are going to, there's more that we need to do, but that's where we're going to stop this video. You have installed your receiver, you've bound your receiver, and we have configured the flight controller so that we have movement in the receiver tab. We now have communication from the controller all the way through the receiver to the flight controller, and we are ready to proceed with the next video in this series. As always, the playlist is down in the video description below, or a card will appear on screen if you're on a platform that shows you cards. I'll see you in the next one.